Okay, this is Sung. I'm the principal and director of Sky Academy. In the last episode, last episode was the introduction to a whole new topic, which was Locus, yes? And I kind of went through a bunch of stuff with Locus. I went through the definition, what is a locus? I actually went through some of the types of locus that you'll find, including straight lines, parabolas, circles, semicircles, regions, etc. Then I actually looked at this part, which are some really useful, if not essential, formula or formulae that you need to know in order to do locus type problems or locus type questions, right? So now what we're going to be doing is launching straight into how to do locus type questions. And I'm going to start by doing some warm-up examples. And if you're really good at this, you actually might not need these formulas at all at this stage. But what will be helpful will be for you to graph what's going on so you can see the rule that governs the locus. Does that make sense? All right, so let's have a look. Some of these questions are as follows. Let's look at the first question. Find the equation of a locus of a point Pxy that is 3 units above the x-axis. All right, so we've got the x-axis here. 3 units above the x-axis will be, say, 3. All right, 3 units above, and it will be uniformly 3 units above the x-axis like this, yeah? Can you see that the equation of the straight line, every single point on this line, this horizontal line, is going to be 3 units above the x-axis. Do you see that? So that distance there is going to be 3, that distance there is going to be 3, that distance there is going to be 3. All of those distances are going to be 3 units above the x-axis, yes? All right, now what could we use? We could have used the perpendicular distance from a point to a line, but common sense tells us, or common sense dictates, that you can actually just graph it and work it out, yes? And that's why I called it these warm-up examples, because what we're trying to do is work out the locus of that path, all right, of that point, all right, just visually, just by looking at the graph. Okay, so here we go. It's basically a horizontal line, which will have the equation, what will that be? Y equals 3. Because every single point on that line has a y coordinate of 3, even though your x coordinate is changing, yeah? So it's y equals to 3. Good. The next question is this. 4 units to the left of the y-axis. So you got your y-axis here, 4 units to the left will be the y-axis shifted across 4 units, and it's going to be -4, right? It won't be positive anymore because we're shifting it to the left. So let's have a look. -4, ... The equation of the locus will be similar to the above question. It'll be x equals to -4. Do you see that? Good. All right, like I said before, we could use the perpendicular distance from point to a line, but we're not going to, right? It's just a matter of visually being able to see what's going on and applying that, okay? The next question, equidistant from y equals to -5 and the x-axis, right? So you got the x-axis is here, and it has an equation of y equals to 0, yes? And its equidistance from y is equal to -5, which is basically -5 units that way. Yes? Good. So, what is the locus of a point that's equidistant from this line and this line? Well, it's the line that's running through it, isn't it? Or the line that's kind of exactly in the middle of y equals to 0 and y equals to -5. Yes? Good. So it's basically this line here. What is the equation of that line? well, what's this height? If this height's 0 and this height's -5, this distance there will be the midpoint between 0 and -5, which is -2.5 or -2.5. Does that make sense? So really, equidistant from y is equal to -5 to the x-axis will be y equals to -5 on 2, or you can write y is equal to -2.5, or you could probably write y equals to -2.5, although, right, when you kind of get into advanced algebra, all right, that is actually quite ugly, yeah? You're better off, and what's more useful for us is expressing that as an improper fraction, -5 on 2, okay? So there we go. There are your three answers, of which these two are probably prettier, okay? The last one here, 3 times the distance to the y-axis as it is to the x-axis, all right? So basically, this one, you kind of do need to use some of these formula, but let me just kind of show you how I would do this. You kind of could use the formula, and you kind of don't need to. So let me show you what I would do. Basically, what I would do is, let's set up our point P. Let's say point P is here, x, y. Now, what is the distance that this point is from the y-axis? From the y-axis, it's this distance there, isn't it? All right? Which is a matter of x units. Good. Got it? And what is the distance that it is to the x-axis? Well, the distance to the x-axis is going to be that distance there, and it's going to be y units. Do you see that? Yeah. And our geometric condition, which we're trying to satisfy, is that 3 times the distance to the y-axis as it is to the x-axis. So in other words, this distance here is 3 times as big as that distance there. Do you see that? All right. So what we're trying to say is that this distance here is 3 times as big as that distance there. Got it? So what we're actually saying is that in order for them to be equal, right, we need to say that 3 times the distance to the y-axis as it is to the x-axis. So we need to multiply the distance to the x-axis by 3 to make it equal to the y-axis. Does that make sense? Right. So in other words, x is equal to 3 times y, because y is 3 times the distance to the x-axis. Because y is the distance to the x-axis, right? And we need to triple that for it to be equal to the distance to the y-axis. Does that make sense? So our answer is x equals to 3y. Got it? All right. However, that's not where it ends, right? So I actually put a star on this question because this it's actually a trick question, right? Because distance is true whether it's positive or negative. Got that? So it's also going to be, all right, it's also going to be the absolute value of x, which is also equal to the absolute value of y, of 3y, okay? All right, which would include this point here, right? Which is basically where minus x is equal to 3y, yep, as well, all right? So it's going to be, our answer is going to be x equals to 3y or x equals to minus 3y. Yep, that's one answer. That's solution 1. Another way of expressing that same answer is the absolute value of x is equal to the absolute value of 3y. All right, and there's another way again, of expressing the same answer. And this will require a little bit of sneakiness. Let me just rub this out so I can actually go through that on the board. Another way of expressing that answer is, you actually have two cases, right? You either have x equals to 3y, or x equals to minus 3y, yes? Right? And here's what we can do. X minus 3y equals to 0, or x plus 3y equals to 0. Yep. Multiply them two together, and we've got x squared minus 9y squared equals to 0. And that's another way of expressing the same answer. X squared minus 9y squared equals to 0. And that's solution 3. And they're all the same way of expressing the same answer. Okay? Now, what will that look like? What will that look like as a graph? Let me graph that over here for you, and I'll do it in black so that it kind of stands out. So if you've got, you've got basically a line that passes through the origin, which has a gradient of 3, and you've got another line that passes through the origin, which has a gradient of minus 3. So the first answer will be that. The second answer will be that. Okay, so x is equal to 3y, and x is equal to minus 3y. Okay, cool. So that's basically a warm-up in Locus, right? In how to do Locus questions. This one here was a bit of a mind stretcher. Okay, it would have stretched your minds a little bit. Okay, but in the next couple of episodes, what I will be doing is going through how to use these formula in Locus type questions, or Locus questions that will require us to use some of these formula. Okay, so the next episode I'll be going through will require us to use the distance formula. Thank you very much for watching.